So in 1998, this will explain better, but I'm going to tell you a little story before we jump into it. 1998, I was working at Koch Industries, and they had worked with the French company Elf Asphalt, who had been selling at that time to a company called Screg. And they had worked on a technology where they said, there's all these grids and fabrics, and what's a fabric? Okay, a fabric doesn't do anything for the cracking delay. It's a fabric that goes down, and you spray emulsion on the top of it, but it waterproofed and it helped cracking maybe a year. Grids are nice, but they have to be so stretched to go in place. They work really well to stabilize soil, to stabilize aggregate, but they're okay with reflective cracking, but really don't solve the problem unless you get them pinned and stretched right. Then, and what grid will do at the edge is it creates these two cracks that come up. And I've used a combination of the interlayer with the grid too on some incredibly large cracks up to 75 millimeters, which is ridiculous, to treat things like that, where you have to cut it out. Then, so we got to thinking, and when Screg brought this over, they said, what's the best way? The concept was, what's the best way to fix a crack? Well, they've come up with these 100 millimeter, 10 centimeter um, lifts of coarse aggregate and to disrupt it. And everybody's had opinions, right? Well, this is going to give you a 25-year look at what we did and how it's worked. And the concept is this: the best way to take care of a crack is to use a dampening system on it. It's no different than what Nike did when they moved from Converse tennis shoes to the composites that they have today. It's no different than when you saw the industry move from cotton, from what we wear, to polyester, to blends of cotton and polyester. One's moisture wicking. We're trying to approach the pavement from a composite side, not just looking at one material. And that's where Surface Tech comes in with a product that can do something very different. And they have allowed me to be able to revamp this, and you'll see what we did today. So a little shameless bragging on my laboratory. This is owned by me. Steve got to come out most recently and see this, but I do have I show this to let you see I have a full performance-based laboratory with aggregate mix and binder capabilities. In the lower right corner, you see this large compactor that I use, and that is that's one I can make large slabs, even do friction testing and so on. Other things that I offer, I guys, as you know this, I get into everything from consulting services, product development, and training, and so on. The product development side, where I've really worked closely with Surface Tech, where they've allowed me to be able to say, what else can the fiber do? Well, Phil, do you think it could do this? What test could help us understand this? And on a commercialization piece, which direction do we need to look at going? And Surface Tech has been one of my number one clients since 2017 when I jumped down this road. Something new that we've added is pavement condition index monitoring, and PCI, as we call it, video monitoring, where it gives an interactive map where you can go and begin to look at it. Surface Tech recently did this, and it's something we add on to it, where I have values of their pavements. George, you saw that in the previous presentation, where we went through and we looked at different pavements and what their life looks like after 5 and 6 years. Now, I'll throw this in there. If I were to look at aramid fiber over concrete after 7, 8 years, it's probably going to look about the same as regular mix. Okay, it's going to show a big delay up front, but eventually it's going to crack because you got a mismatch of materials. By using the interlayer and the fiber, you can begin to remove cracking altogether. I'm not going to say we can remove reflective cracking and stop it, okay, because it's going to come through at some point. But I'm going to show you data that I think you'll be pretty impressed with over what we can do. So the background, as I mentioned, was reflective cracking is anytime we tend to do a mismatch of materials with rigid over asphalt. When you put anything over this picture on the left, the crack will show through. And especially the transverse crack. Longitudinal cracks, not as much. Corner breaks, not as much. Mid-slab cracks, not as much. But where we have done a saw cut and have a defined joint that wants to move up and down, that load transfer from one slab to another typically starts to drop below 90, and now you've got a movement that can be pretty significant. When in the early 90s, they were being used with various levels of success. For the French called it sand anti-fissure, but they never really could get it to take off because they never addressed the different climates that we may see. 1998 is when I jumped onto it, and it was Coke is a very large polymer supplier, and they saw this as a really good play for us, and a really good way that if we developed high strain polymers, not any polymer would work. Matter of fact, a lot of people tried it, but to get something that would go, for instance, in a fatigue device, George, you just got through seeing people run tests in a fatigue device at 2 and 300 microstrain. I was running tests at 2,000 to 3,000 microstrain. Not 200, not two, not yeah, you get the idea. I'm operating at 2,000 microstrain, which is unbelievable. The machine itself begins to want to jump off the table, and you have to have it in the chamber. It goes into resonance if you don't adjust it right. So I like to think that this material, as a VP told me one time, I broke a machine. It cost $20,000 to repair, and he said, Phil, you seriously broke a machine with this, and it was Brian Majeska, Steve. He said, you broke, and I'm putting my head down. I'm feeling bad. And he said, no, Phil, this is absolutely awesome, incredible that our new material broke a machine. So a neat way to think about it. Now, what looks really simple, guys, is a razor edge design. It's a 4.75 millimeter mix, usually placed about 25 millimeters thick. Asphalt content, I'll tell you, even goes 8.5 to 9 to 10% asphalt. Impermeable, and you look at this and you say, there's no way it's going to work. Just wait, and I'll show you, because this is areas I like to do the things that people normally don't do. In 2000, we saw varying levels of success because we were trying to do the same thing the French did. We had one product, we were putting it down everywhere. So what we did, we began product development, and I pretty much didn't travel for 2 years, and began putting down products in the northern U.S. to the mid to the southern. So from near Minnesota all the way down into Texas and across the U.S. Same time, I was putting them down in China. China took off with this, and they probably today put down more. They took the technologies pretty much, kept the technology. Won't go into that one, and kicked us out. And but absolutely loved it. One thing that we found out was that we were looking at 4-point flexural fatigue, but we're not just doing it at 20C. We're doing it at 15 and 10C. So we began to base this system on climate, and we're looking at in-place air voids of 2 to 3%. Not your typical 7 to 8%, but 2 to 3%. Makes a lot of person really nervous. We used a beam stabilometer back then for rutting. Now, one thing that I want to add, and I know somebody wants to ask the question, did we ever have a pavement fail and rut? Not one. Not one of the to date. I've done probably 27, 28 installations in the U.S. Not one ever rutted, going back to 1998. And a lot of these are on high traffic routes. Can it be used over asphalt pavements? Absolutely. Could you use them in parking lots? Yes. The only pushback on this is that you've got to have a decent overlay thickness to protect the interlayer. And we'll talk about what that looks like. You cannot leave the interlayer exposed to traffic, high traffic, for instance. And we could design it so you could do so, but the problem is where it's impermeable, it becomes slick. And that's why you really need to be able to cover it up. So in 2002, 2006, we continued on with our development, but we also worked with University of Illinois. We worked with Bill Butler, Ishan Dowie, with the time he was still there, a young man named Song who's now with Caltrans, and a guy named Wagner who worked over in Pennsylvania. So we had a goal. This was called the National Science Foundation Grant Opportunities Liaison with Industry. Big word to say that we worked together with the university on a $250,000 project to begin to take the $1 million that we've already put into it and now add more to it with modeling. I don't know if any of you have heard of the DCT test. The DCT was developed out of this project. Steve, I know you've heard about it. This is where Phil Blankenship first met Ishan Dowie, who is now considered somewhat the father of the DCT, along with Bill Butler. So this is why I've got a gray beard. It's a long time ago. Now, 25 years after introducing this, and I say 21 to maybe 23 now, 25 years after introducing this into the U.S., it is now used at some level in the U.S. across many different states. Adoption slowed due to the lack of understanding. Some people tried to water it down. Some people said, we don't need the high asphalt. We don't need the high polymer. They put it down, and all of a sudden they go, well, now does it really work? And and you begin to degrade the specification. Today, if you go and look at it, I've had the chance to watch one for its full life, put down in 2007. They replaced the surface in 2017, 10 years later. They went back down. The inner layer is still intact. They've done that on several jobs, but one really close to where I'm at. Steve, you drove over it going back up to the airport from my place to Cincinnati. And you would never know there's concrete there, because not only does it delay cracking, but it also does a remarkable job at offsetting the cracks, so you do not even know there's concrete under there. You don't hear the ka-thump, ka-thump. You can use other tests, DCT, ideal CT, that correlate with flexural fatigue, and I'll show you how that works. And then what we found out is that aramid fiber is a direct replacement for original high polymer asphalt design, and even gives this another kick that we weren't able to do before. I think it's made it a lot better product. Some examples is one we started, and there's actually the reason I mentioned this one, there's a TRR, Transportation Research Record paper on this. And by the way, George, I was talking with a friend of mine, and there's several places where I was wanting to publish some stuff, and I've decided, instead of keep kicking it to the U.S., I may just start putting some stuff your way and over in Australia, and that'll give me a reason to come your way, right? So, but it's also a good way. The Australian research records and so on is a really highly respected consortium over there, just like what TRR, Transportation Research Records, are here. So this made it into the Transportation Research Records. And this one, they went in and they did I show you different techniques, right? This case, they did a V-milling technique, because these joints were just completely destroyed. And we put the interlayer in, and actually the interlayer went all the way across, but showing you how that we overlap the joint probably about 15 centimeters. We tried to overlap the joint so that you did not have a joint on top of another joint. From that technique's taken off in the U.S. today, where they do a lot of that overlapping, not just with the interlayer. They've done that now with others. That we used to build joints on top of joints, which was not right. Just to convert this over, as you guys know, here you're looking at a 250 millimeter pavement with a 25 millimeter interlayer. On this right here, you have a 100 millimeter overlay. So that's pretty typical. And that concrete is what they did not want to take out of place. I love rubbleizing, but the moment that you rubbleize, you just devalued your whole concrete pavement. So this is a way that we can leave the concrete in place without having to shut down these pavements for a long, long time. This was the project in 2004, and just to let you see that. And then there were studies they began to look at, and after 2.5 years, they began to see, in the early years, there's not a lot of difference, but then they began to see, after a while, the interlayer, now this one jumped up, but the interlayer began to outperform early on. Now this was just one time. This was from the paper that was done in 2004. After I left Coke in 2008, I didn't follow it up anymore. But some pictures that were interesting. The control had very defined cracks as compared to what the interlayer cracked. And this was a bad pavement, folks. The interlayer had a hairline crack versus this massive crack. This went all the way down to you can't see it well, but it goes all the way down and allowing a place for water intrusion. This one actually was offset so that the original joint would have been about 3 feet over here. Matter of fact, we went and tried to understand on pavements like this. We began to chase these cracks here, and we could chase them right down to the joint. Here, the joints were up to 3 feet. So that'd be about a meter, George, I guess. These were about a meter offset. The cracks were offset at 45-degree angles from over this pavement. This again, is a 25 millimeter layer. I want you to look at this and what it's doing. This part here, it was completely intact. So the water path was cut off. That is when we knew that this interlayer was much more than a crack delay. It improved rideability. It improved long-term life because it removed the water from the base and so on. We then went to a very cold region in Decorah, Iowa. This is one where we believed we had nailed it. And what I did was the picture on the right this is one after about 4 years. No, let's see, 3 winters over 4 summers, so 3 winters. I took a picture on the right. I'm in the middle of a roadway. People are watching, but it's Iowa, so there's not a lot of people out. You just have to be there to understand it. And so I'm in the middle of a roadway, people watching my back, and I take a picture how they've already treated. Look at the reflective cracks. Look familiar? The interlayer section was behind me, so I did a 180. I turned around and took the picture on the left. Can you see a difference? Now, what's amazing between this and this roadway's already had maintenance, so they've already spent thousands on this. This one, they didn't spend anything on. And that's in a cold area. That was just remarkable. So we go on to move forward, and I'm working on a project with an engineer friend of mine. I'm on a consortium in Kentucky for general aviation airports, where we're writing specifications. I do a lot of work on that. And one of the things that came up was we had this early micro cracking, and they said, we want to build up this pavement surface, but when you deal with airports, you really don't want to mill anything off. You always want to leave the structure intact. And that way you can have heavier loads, and your airport gets upgraded. So they wanted to put down an interlayer, and Gary said, Phil, can we do it? I said, the problem is I can't get the asphalt product anymore. And I started scratching my head. I called Steve. I said, Steve, do you think in 2 weeks you could help supply something? Because I want to try this. Sure enough, Surface Tech got in place, was able to put fiber on this job. It actually ended up being less expensive than the interlayer of old, because now we're using fiber, not specialty asphalt. Turned out it was a direct replacement, if not even being better. That you may say, okay, Phil, you done a lot of talking on this, but what does this really look like? This was one where we went over asphalt. We weren't directly over concrete. But what's this product look like? This is the product in the hopper. You can see the fiber. You can see what it looks like down here. And I'm going to play a video, and I want you to watch how much this pavement moves with a roller. Think about this. This is not for the average person to do. This is 8.5% asphalt. It has aramid fiber in it. You're looking at about 8% dust. It's a fine graded mixture, and it's 25 millimeters thick. And watch what happens when you put a roller on top of it. By the way, everybody gets nervous, and even the roller guys will tend to not want to roll it. And I have to sit there and look at them and say, guys, put the roller on this. You'd never know it's an interlayer, would you? Pretty incredible. It's not pushing laterally. And that just goes to show you, we've got to really get out of the box of where we'd normally be. When I say 1/8 inch per inch, it would, so for a 25 millimeter layer, you're probably looking at it compacting about 4 millimeters, on a 25 millimeter lift versus the standard 8 or so that you would see. Very, very dense mixture. At the end of my tenure in 2006, on the projects looking at where we used a proper overlay, where we had used the fatigue cycle, the 100,000 plus fatigue cycle interlayer, 18 projects up to 4 years old, we saw an average improvement in reflection cracking of 71%. Steve, my favorite comment that I got on this was from Canada when I presented one time. They came back and said, that's really interesting. Do you not have any data past 4 years old? I said, I challenge anybody out there to track 18 projects for more than 4 years. I don't know of many agencies that track them for more than one, but we did. And 71% improvement. This is what a mixed design may look like. So I want to walk through notice there's no
what
wrap
does
in the interlayer.
71% improvement mean?
What's that?
You're saying 71% improvement. What does that actually mean in comparative to something else?
71% improvement in reflection cracking. So in the cracks that you would see that would reappear, it was you had 71% less cracks when you use the interlayer. 71% less.
That's compared to just a standard overlay of, say,
a standard overlay.
You're saying there's 71%. Okay, that's all right. Just because I wasn't sure.
Great question. As compared to control sections of a standard interlayer. That's it. Okay. I'm sorry, of a standard mixture.
The standard dense.
So what we began to say is this type of mixture roughly doubled the life of whatever you put on top of it. It was made to absorb any type of distress, top down, bottom up. It's a buffer of an interlayer. I've even seen this. I've even seen a concrete pavement blow up during construction of the interlayer with the interlayer on it. The next day, the concrete pavement has blown up and the interlayer is still intact. You know, it's ridiculous how well it absorbs movement. I don't make it being I guess it could be ballistic interlayer if we put aramid fiber in it, but that's not the goal of it, right? So this is a mixed design example. So Peter, George, I don't know if I've ever shown this to any of you guys before. Maybe you've seen something like this, but this really gives you an idea. Notice in here that these are fines. So all of these materials are minus 4.75. I'm using things that a lot of people would throw away. This is a dusty aggregate. This is this is a clean aggregate. This is a regular sand. This is a dirty aggregate, and this is typically what we're doing, right? And it's a fairly dusty mixture. Notice I put the aramid fiber, and in this one I've got a double dose in this thing, or 4.2 ounces per ton, and I adjust that as I need it. Sometimes I may have to go up a little higher, but typically I'm not going to be below the 4 ounces. In this case, that would be, you see a single dose is about 66. So yeah, you're looking at like 132 grams per metric ton.
Hey Phil, just one question. So what you're doing here then, you're not, the binder is just a standard non-modified binder, is that correct?
Well, this one is a modified. So what we did to take it up a notch, George, and that's a good question. I need this one. They used a little higher modified one. I need what I like to do, the poor man, I call it a poor man's version of this would be, let's use your standard binder. Okay. So that's sort of a poor man's interlayer that would work well for a parking lot or things like that. If I want to really take it up to its full potential, and I'll show you what I mean by that in a moment, take it to its full potential, like what I've been talking about, we need to use a lightly modified binder. So in your case, you don't want to use a stiff asphalt. Use one that's sort of a grade softer of whatever that would come in. I'd have to work with you guys to make sure I've got it in the right category. But we want to be a little softer than your regular one. And if you had a light loading of polymer, that's ideal. Why is the polymer important? The polymer adheres really well and helps the bond between the aggregate and the fiber. And when you add the polymer binder with the fiber, you get an incredible benefit. When you just use the polymer, just use the fiber, you're going to get, it's good, but it's not next level. When you combine the two technologies, it's incredible. You do not have to use this highly modified binder. You can use a lightly modified binder. And I've got to believe you would have, when I say lightly modified, maybe 2% polymer, George.
Yeah, got it. That makes sense. Thanks.
Okay, so this is what a grading. Now, again, I'm using US sieve, the US sieves here, but the number 4 would be a 4.75. This would be a 2.36 millimeter. This would be a 1.18 millimeter down to our 75 micron over here. You see the grading over here with the metric. That gives you an idea how fine that mixture is. This is, this is a max density line. So, and what's happened, I've actually produced some that's way up here at the top. And when I do that, you'll actually have voids that you can't fill. You can create a permeable mix, but we like to go impermeable. These are the typical gyrations and the volumetric properties if you're looking for it. The VMA can be approaching 20%, VFA is 93. I mean, these are just ridiculous numbers. And I love it because this is the stuff. If I were bringing you something that you did every day, why would you want to try it? We're trying to fix a problem that nobody else has fixed. And that's why this mix works. So when you take the uniqueness of this mixture with the high asphalt, with the stability, combine that with a softer grade of asphalt with the double aramid fiber, you get this incredible combination of materials. On an ideal CT, and I think this is sort of fun to show you a little bit, what I mean by very unique, I could show you beam fatigue, but I want to show it to you in ideal CT. A normal mixture may have a 153. Have you seen a decent amount of ideal CT data, George?
Yes, I have. It's something that,
okay.
Yep.
Yeah. So a number.
Sorry.
Yeah. So a number over 70 to 100 is really good. Okay. This is a 153. Now look at the temperature here. Okay. I now look at the interlayer with 8.2 asphalt, 25C, with this is a very lightly modified grade in the US. Double fiber in this interlayer, and look what I went from a 153 to 1712. Unbelievable. And that's that 10 times, it's 10 times more flexible. And if I had a sample in front of me and you see me do it, I would be bending it here in front of you. And you still have your samples, George?
Yeah, you carry on, I'll grab one.
You showed a picture of it earlier.
Yes, it was at the beginning. I know George has some, so we have some fun with it. These other bars represent what we do is if we wanted to go to a cooler climate at 20C or an ultra cold climate at 15C, it's the same mixture. I just take my asphalt grade and I go down a grade softer, still using the double fiber, and I can still get this relative 10x or more. Oh, that's it. That's pretty cool. So George, the one in your hand there is probably close to about a -28 grade asphalt. It's probably this one here, the dark blue one. But I was showing them, George, that if I wanted to go to this is a warm climate, a hot climate, I can go to a warm climate or a cold climate. And so again, we adjust the test temperature based upon the climate and adjust the asphalt grade. So in the US, if I'm dealing with a place from the northern US to the southern, we change the asphalt. What we're not changing, we don't change the mix design. We're not changing the fiber. What we are changing is the binder to get a softer binder to allow it to be more compliant. With that, these are some of the values that I'm using a Hamburg today. And these were values I sort of recommended for Pennsylvania. As you saw what I put in there that we're coming up with. And again, advantages, and I didn't talk a lot of this at the beginning, but it significantly delays cracking, as I mentioned. Impermeable, and it does force lateral drainage. So you got to think about that. If you're depending upon vertical drainage, this will force lateral. So as you put it up near the top, you're going to want to daylight your water to the side of the roads. We have performance-based specs. Whether we're using fiber or chewing gum in this, these tests are meant to identify performance. Fiber is my go-to because it just works. And it's easy, and they got an EPD rating, which gives it even a higher benefit. Can be milled, but you can leave it in place. Uses standard construction methods, locally available materials, and very quick construction time and return to traffic. What I did not mention is a site selection, and George, I will package this up and send over to you so you'll have it. But in this case, I mentioned that you want to have you can use it by itself, but using it with a fiber reinforced surface or some type of crack resistant surface makes the interlayer even better. It's sort of a 1-2 punch if you want to think about it. PCC joint transfer of a 70 or better. Can you use lower? You can, but at some point in time, the PCC pavement is in such bad shape. You know, we can make a good pavement great, but you know, we can't make miracles happen. So if your road's falling apart, we can cover it up and make it. Pennsylvania was a state, and they said, "Is it going to help our pavements?" And we said, "How often are you overlaying?" They said, "Every 4 to 5 years." I said, "Well, we're going to take you out to probably 7 to 10 years. They said, "That's great." and that's where we were with it. The interlayer you can actually knead, or it will penetrate into your cracks or joints. Joint seal sometimes can bubble through because it's impermeable interlayer, but it does not affect the performance. I prefer to leave some asphalt over the concrete so you do not have to mill to the concrete, or you can use a leveling course over the concrete. So again, it's very paver friendly, and we just need to avoid trapping moisture after a rain because it's an impermeable interlayer. When I go to construct it, you know, here's we typically cover within 5 days of placement. Open to traffic after it's cooled. It says 150 Fahrenheit. So what would that be? That would be 70 C or so, somewhere in there, I think. And you do want to put tack or a bonding layer on the interlayer, at a normal shot rate for a smooth surface. So again, I'm using a steel wheel roller on it in static mode. This is again really, really easy to pave with. These are references. One thing I did not cover, and I do want to mention this, is that concerning traffic, extreme high loading, you need 75 millimeters of overlay. and I can give you what I call easels, but that's going to be a little different than Circly software would do. But I could give you the easel loading. Medium level interstate traffic in the U.S., we would typically be putting about 50 to 60 millimeters over top of it. If I have a really light loading, I just need to get somewhere like 35 millimeters over top the interlayer, and you're good to go. So 35, let's say sort of 35, 60, and 75 to 80 millimeters. So this is going to be your overlay thickness depending on traffic. With that, I'm going to turn this off, guys, and